Morning, sir.
Am I audible? Yeah. Okay, right. First, regarding to increasing, decreasing. First, I'm going to explain you few steps. Okay, nothing but working rule. I'm going to write the working rule so we can follow those steps. Okay, so this working rule is very, very important. Right. That working rule, you have to remember few steps. And the first one is, so if f of x is given, it may be any function, it may be trigonometric, it may be algebraic, whatever it is. So what is the first step? We have to calculate according to method 2, calculate f dash of x. Am I right? This is the first point. And second point is that, so factorize it. We have to factorize. Factorize it. Okay. So we have to factorize the given f dash of x. F dash of x is equal to, we are getting some function. If it is a quadratic equation, we can factorize it. It may be cubic, it may be biquadratic. Okay. If it is a polynomial, we can factorize. If it is any trigonometric, so we have to take the general solution according to the given interval. Okay. And third one is, so what is the third point? Okay, after factorizing that, so we have to put f dash of x is equal to 0. We can put f dash of x is equal to 0 to find so we get some x values to find the critical values. Okay, to find the critical values. And so whatever the x values we are going to get, when we equating f dash of x to 0, those points are called critical point. So once we get the critical points, it may be 1 point, it may be 2 points, it may be 3 points. Once we get the critical point, we can arrange these critical values in ascending order. Okay, if it is a real line, like if they don't given any interval, we have to take the real line minus infinity to plus infinity. So whatever the critical values we are getting, in that we can arrange ascending order. For example, x is equal to -1, 0, 1 is there, -1, 0, 1. We can arrange the order, first -1, next 0, next +1. Okay, the fourth step is we have to arrange. So arrange these values, arrange the critical values in, so in which order? In ascending order. In ascending order. Okay, fine. After arranging the ascending order, so what shall we do? What is the fifth point? Fifth point is that we have to form the interval. Form the interval, right? So after form the interval, we have to check whether f dash of x is greater than 0 or lesser than 0. Okay, if it is greater than 0, since we know that it is strictly increasing, greater than or equal to 0, just increasing, lesser than 0, strictly decreasing. So lesser than or equal to 0, just decreasing. Okay, check the sign of f dash of x. Sign of f dash of x. Nothing but what shall we do here? We have to take 3 points. 3 points are, first is interval. Next point is sign of f dash of x in that interval. And the next is nature of,
Sir, can you move up, sir, 1 minute?
yeah, sure. Okay, next is
Okay, sir.
nature of f of x. Nothing but it may be either increasing or decreasing. That we will write. So first one is we have to calculate with a given function. We can differentiate. After that, if it is an algebraic function, we can factorize it. So next one is f dash of x is equating to 0 in every question. So once we equating to 0, we are going to get a critical values, critical point, x values. So those points are called critical values. So we have to arrange these values in ascending order. Okay, ascending order. Then form the interval. So we can like form some disjoint intervals according to that. Okay, so then check the form the interval. After that, we can check the sign of the f dash of x. If it is f dash of x value is greater than 0, like we know that everything, right? Let us see the problems then. So here simply remember students, to easily steps to some steps are there. In that we have to select a few steps. That is nothing but first what shall we do here? So we have to first f dash of x. Simply remember f dash of x is equating to 0. Next second point is find the critical points. Critical points. Second point is find the critical point, and third point is checkpoint. Like checkpoint means we have to find those points. We have to arrange the ascending order in okay, divide. First we have to divide and rule and checkpoint. Then we can conclude that. Conclude means whether it is increasing or decreasing. So remember these 6 steps, it is more than enough. Every problem based on these 6 steps. Okay. Right. Yes, here, if you see some example, sign of f dash of x, nature of the function. Nature of the function. So we have to take the interval. In that we have to check f dash of x is either greater than 0 or lesser than 0. Since we know that f dash of x is greater than 0, increasing, lesser than 0, decreasing. And okay, sometimes what will happen? So if we divide the interval like this, in case the function is, 0 to pi by 4 is greater than 0, and pi by 4 to 5 into pi by 4 also greater than 0. In both the interval, it is 99%. It should not be like this. Okay, in one interval is it greater than 0, next interval must be lesser than 0, next greater than 0, greater than, lesser than, greater than. We are getting alternatively almost 99% of the problems. Okay, but in case in both the interval it is greater than 0, nothing but it is increasing, then what about this common point pi by 4? This point is called point of inflection. Point of inflection that we will see in maximum minima. Okay, in both the interval either it is greater than 0, or in the both the interval either it is both will be lesser than 0. Then this common point is called point of inflection. It might be happen in only 1% of the problems, right? So that we know already the difference between strictly increasing or increasing. The function may be graph like this. This is a function, it is just increasing. The graph of the function like this. This is strictly increasing. The graph of the given function is like this. This is decreasing. The graph is like this, strictly decreasing, like that. Okay, so you should have idea about strictly increasing, decreasing. Okay, already we have seen few questions in previous class till question number. What are the questions we completed? Yes, Amma?
Sir, 61E we were doing, sir.
Shall we do again that sixth one?
Okay, sir. Yes, sir.
Yes, sir.
Okay, sixth. Yeah, sixth. E. So the given function is f of x is equal to x plus 1 whole cube, x plus 1 whole cube, and x minus 3 the whole cube. Let us take this as equation 1. So what is the step 1? First one is we have to calculate, means f dash of x, means we have to differentiate. So differentiate equation 1 with respect to x. Okay. So here f dash of x is given by uv rule. So let us take this as u, this is v. So chain rule. First, what is the formula here? That we know that the formula is, since d of uv is equal to uv dash plus u dash v. So x plus 1 the whole cube into x minus 3 v dash, x minus 3 whole cube derivative is 3 times of x minus 3 whole square. Okay, that is the derivative, plus x minus 3 whole cube into u dash. U dash means x plus 1 whole cube, that is 3 into x plus 1 the whole square. Is it clear? Since the derivative of x cube is 3x square. Derivative of x cube is 3x square. That's it. With help of that, I differentiated. Now, any common here, the common is x plus 1 the whole square and x minus 3 the whole square. And 3 also common. 3 also common. Okay. 3 into x plus 1 whole square, x minus 3 whole square. The least power of the function we can take as a common. So remaining value here, x plus 1, remaining x plus 1 here, plus x minus 3. Okay, so this is equal to 3 times of x plus 1 the whole square, and x minus 3 the whole square. Remaining value is 2x minus 2. This is f dash of x. Okay, first one is completed. Next, if it is a, if we have to factorize it, factorize, already it is in factorized form. Okay, factorized form. Okay, then next one is f dash of x. Third point is f dash of x equating to 0. Then we'll get a critical values. Critical values. So next step, now I'm
So can you show
equating.
the starting of the question, sir?
Yeah. Okay, now I'm equating f dash of x to 0, then 3 into x plus 1 whole square, x minus 3 the whole square, 2x minus 2. That we have to equating to 0. That we have to equating to 0. From this, you have to find x values. Okay. So when I equating to 0 here, 3 should not equal to 0. And x plus 1 the whole square is equal to 0. And x minus 3 the whole square is equal to 0. And 2x minus 2 is equal to 0. So x plus 1 whole square means x1 plus 1. X minus 3 is equal to 0. And 2x is equal to 2. So from this, x is equal to minus 1, x is equal to 3, x is equal to 1. Is that clear, students? Okay. So these are the critical values. Values f of x. Yes, is it clear? So in each and every question, you should write the proper steps like this. So these are the critical values of f of x. Now, what shall we do? So remember, students, in the question, if they mention show that question, every show that or prove that question, definitely they'll give interval. Okay, show that. See here, interval they given x greater than 1. X greater than minus 1 means It is open interval minus 1 to infinity. This is the given interval. In that interval only, we have to check given function increasing or not. So see here in even remaining questions also, any question, if they give show that or prove that, they'll give the interval. See here, interval is given. Here interval is given because prove that. Okay, prove that interval is given. So which of the following, here they did not ask any like show that or prove that. So we have to find the functions like 0 to pi by 2, like which of the following functions are decreasing. Okay, like that. Prove that means they give an interval. Okay, so if they do not given like show that or prove that, we have to take the interval as real line. I already told you, minus infinity to plus infinity. Okay, in this question they did not uh, is here they given any, okay, show that and throughout its domain, throughout it. Okay, so which question we are doing? Okay, sixth one we are doing. So in this question, they did not given any interval because they do not ask show that. Okay, simply they are asking the interval in which the function is strictly increasing, decreasing. For that, we have to take the interval as real line, real line. So I'm going to take the real line here. So the real line is minus infinity to plus infinity. Draw the real line. So look at here, students, minus infinity to plus infinity. This interval we can divide into sub interval. For before that, see what is the next step? We have to arrange the values in ascending order. So what are the values we got? Minus 1, 1, 3. So first minus 1, here 1 and 3. I are arranged in ascending order. After ascending order, we have to see here, we have to divide the disjoint interval. What are the intervals we are going to get? One is minus infinity to minus 1, minus 1 to 1, and 1 to 3, and 3 to infinity. These are the disjoint interval we are going to get. Disjoint interval we are going to get. Okay. So right, arrange the values in ascending order, form the interval. So then check the sign. Okay, look at here. So form the interval. Interval means, see, we'll do like this. Yes. See, first we have to take interval. Next, we have to check the sign of f dash of x, nature of the function. Interval. Okay. So here, first interval, sign of f dash of x. Next, nature of, nature means the function increasing or decreasing. In the otherwise you can write sorry, I by I nothing but increasing, d nothing but decreasing. Okay, you have to take that bracket. Okay, right, students. So here again take the nature of this. Here not necessary that to draw the graph of the given function. Clear? Right. First, yeah, right. What are the interval, Amma? Can you tell me here? We can divide the intervals, sir. Minus infinity to minus 1. This is the first interval, and second one minus 1 to 1. Next 1 to 3, and next 3 to infinity. So in that interval, we need to check the sign of f dash of x. How to check the sign of f dash of x? So first, what is f dash of x? We got it here. F dash of x is, remember this. Sorry. This is the f dash of x. Okay. So if possible, you have to write here f dash of x value 3 into x plus 1 whole square. If possible, you have to write the function here. F dash of x is, I'm going to write here f dash of x values. Okay. F dash of x is equal to 3 times of x plus 1 the whole square, x minus 3 the whole square, and 2x minus 2. Okay, right. So how can we check the sign? See here, minus infinity to minus 1. You can take any value from minus infinity to minus 1. You should not take minus 1. Because at minus 1, f dash of x becomes 0. Or okay, other than minus 1, other than 1, other than 3. Except these 3 values, you can take any value according to. Okay, what is the value we want to take here? Minus infinity to minus 1. Shall I take minus 2? Yes. Minus 1 to 1. Simply you can take 0. And 1 to 3, you can take 2. Try to take integer values. Even we can take real values also. Here you can take try to 4 or 5 or something. Okay, so what is f dash of x? Substitute here in the f dash of x minus 2. What about the sign, student? Greater than or lesser than? You only tell me. Substitute here. Minus 2 plus 1 minus 1 square is positive. Square means positive alone. Square means these two values positive, whereas just they have to check 2x minus 2 values alone. What is 2x minus 2 value? The square means it is always positive. Negative or positive? Negative. Negative means lesser than 0. Whenever lesser than 0, what is the nature? D or I or D? Yes, I or D. F is decreasing. Like that you have to write. F is decreasing. Here lesser than 0 means strictly decreasing. Okay, right. Now, minus 1 to 1. Minus 1 to 1 means simply put 0. 0 means again first two values are positive because square is there. 2x minus 2 value. Lesser than or greater than? Lesser than 0. Am I right? Same f is decreasing. Then what about 1 comma 3? Students, lesser than or greater than?
Greater than.
Yeah, it is greater than 0. Here, then at last, greater than 0. Nothing but f is increasing. Here also, same f is increasing. So here, look at here, in these two interval at minus 1, so what do you observe here? At minus 1, the function, this is the common point for the both interval. So, and both will be lesser than 0, lesser than 0. This minus 1 is called point of inflection. Point of inflection. Point of inflection. Here 3 also called point of inflection. Means, so here, so finally what we conclude here. So for what, in which interval it is increasing or decreasing? See, increasing means simply you can give this symbol, increasing. So this, sorry, not increasing, that is decreasing, first two intervals. Decreasing, decreasing, and next two intervals it is increasing. Okay. Therefore, what shall we write finally? Finally, what we can write? You have to write the steps like this. Finally, you have to conclude. Therefore, f is increasing and decreasing like that. Here we can write therefore f is increasing in the interval minus infinity to -1, -1 to 1. Because why don't we write here -1 to directly 1? Is it possible to write minus infinity to 1 directly?
No, sir.
Yes, because at -1 it is point of -1 is a point of inflection. Next, decreasing.
So f is decreasing from minus infinity to -1.
Oh, sorry. Increasing. First, I'm going to write increasing. So that otherwise, here you can change it. Right. Okay. Decreasing, increasing. 1, 3, 3 to infinity. Okay. Right. Student, what we have done? First step is f dash of x. Calculate f dash of x and equating to 0 in every question. We are going to get a critical values of the given function. So at the critical values, you can arrange in ascending order on real line. If they don't give any interval, we can take minus infinity to plus infinity. If they're given any particular interval, you can take that least value, highest value in between. You can arrange the critical value in ascending order. After ascending order, we can divide. We are going to get subintervals, disjoint subintervals here. So what are the subintervals here? Minus infinity to -1, -1 to 1, 1 to 3, and 3 to infinity. So in that intervals, we have to check sign of f dash of x. So that sign of f dash of x will represent nature of the given function. Either it is increasing or decreasing. So lesser than means decreasing. So it's simply you can write down here strictly decreasing, strictly increasing. Okay. Yeah, because in the question they are asking strictly increasing, strictly decreasing, right? Is it clear, students? Okay. Till end of the problem, like in all the question till question number 19, we can follow the same steps. Any doubt? Okay, I'll be post this slide in your class room. You can check it once if you get any doubts. Next question number 7. Show that, already show that they given what is the function they given. Show that y is equal to log the function y is equal to log 1 plus x minus 2x by 2 plus x. Interval is -1 to infinity, is an increasing function throughout its domain. Domain means we have to show that a given function is increasing, enter this interval, like throughout this interval means -1 to infinity, we can show that it is increasing. That's it. That interval we can show that it is increasing. Simple. Same. First, what shall we do? F dash of x. First one is differentiate. F dash of x means if I take y is equal to f of x means f dash of x. F dash of x is 1 by 1 plus x minus. Okay, what is the derivative of 2x by 2 plus x? U by v rule. What is the formula for u by v? V u dash minus u v dash by v square. Right, students? Okay, v u dash. So 2 plus x into 2x derivative is 2 minus 2x into 2 plus x derivative 1 by v square. V square means what? What is v? 2 plus x the whole square. I hope that everyone understood this is an easy differentiation because 2x derivative 2, 2 plus x derivative is 1. So after that, okay, so 1 by 1 plus x here minus multiply here. So 4 plus 2x minus 2x by 2 plus x the whole square. So finally, f dash of x value is what? 2x get cancelled. Then 2 plus x the whole square. You can take LCM. 1 plus x here. 2 plus x becomes here 2 plus x the whole square. Minus 4 times of 1 plus x. Like that we will get. Okay. Then after. So what is the next procedure? After getting f dash of x, to find the critical values, f dash of x equating to 0. F dash of x. Now, f dash of x equating to 0. F dash of x value is 2 plus x the whole square minus 4 times of 1 plus x by this values. Like 1 plus x, 2 plus x the whole square equating to means. See, denominator, when we cross multiply, it will become 0. So here 2 plus x the whole square becomes 0. So students, all of you find that x values here.
X is 0.
X 0. Okay, when we simplify this, okay, all of you simplify this. 2 plus x
It
the whole
becomes x
square.
square.
X square. Okay, x square plus 4x plus 4 minus 4x. Just x square. Okay, fine. Okay, 4 get cancelled. This is equal to x square. Okay, x square is equal to 0 means which implies x is equal to 0. See here, critical point is x is equal to 0. What is the critical point? Critical point we got x is equal to 0. But already given an interval. Because the question is show that, so definitely they'll give an interval. Interval is minus 1 comma infinity. We do not take the real line here. So whatever the interval they given, that interval alone we have to take it. If they don't give any interval, you can take minus infinity plus infinity. So minus 1 to infinite they given. There is a critical point we got is x is equal to 0. X is equal to 0 is critical point of f of x. Okay, so how many subintervals we got it here? 2 intervals. Okay, first again same like above. First what shall we write? Interval. Then we have to check the sign of f dash of x, nature of the function. Like that, those 3 points we have to write. First interval, sign of f dash of x, nature. Okay, students. Same interval means minus 1 to 0 and 0 to infinite. 2 intervals. So what is f dash of x, students? Minus 1 to 0 means you can take any value. Like you can take 1 by 2, minus 1 by 2. Yes or no? Take minus 1 by 2. Here minus 0.5. Substitute here. given function. It is square means it is clearly positive. Yes or no? Positive denominator is minus 1 by 2 means this is positive, this is positive. Overall, yeah, anyone? Okay. Students,
Greater than 0.
is it greater than 0? Because see, in case if we get a lesser than 0, you have done somewhere mistake, because already they asking show that it is increasing. Increasing nothing but see, and throughout domain it is increasing means what shall we get here? So no need to check anything, simply can write greater than 0, because already asking show that. So greater than 0 only it is increasing. So f is increasing. Here also f is increasing. Finally, what we can write? Therefore we can write therefore f is increasing throughout domain. Increasing in x greater than minus 1. X greater than minus 1 means throughout its domain. You have to write like that. Clear, students? Or any doubts?
No, sir.
Okay. In each and every question, we'll do like that. We have only 1 minute more. So here also just find the values of x for which increasing. See, student, in that already they give an increasing function. Okay, already given increasing. What is the condition for increasing function? F dash of x is what? Greater than or equal?
Greater than or equal to.
Yeah, you have to take directly. Find first f dash of x. That f dash of x directly you can take greater than or equal to 0. You are going to get some x values. That's it. Those values we need to find. Here also we need to find just critical values. Yeah, no need to check increasing and decreasing anything. Okay, already they given increasing. Just find the required x values. Next question, prove that it is increasing function in this interval. Already given, prove that. Prove that means definitely they'll give intervals. Interval is given. So what shall we do here? Find y dash. Okay, y dash and equating to 0. Equating to 0 will get some critical point. At that critical point, we can divide it into subintervals. In each subintervals, it is greater than 0. That's all. Subinterval means real line here 0 to pi by 2 alone you can take. Critical point we should get here some value like it may be 30, 45, 60 like that. In case if you are getting negative values, for example minus 30 you get, you don't consider that. That value not belongs to the given interval. Okay, critical point, for example, f dash of x equating to 0, we may get a minus pi by 6 or pi by 6 or pi by 4 something. See, we have to consider these two values alone, because these two values alone belongs to given interval 0 to pi by 2. But when you take minus 30, is minus 30 is belongs to 0 to pi by 2? No. At that point, no need to check it is increasing or decreasing. Okay, same here also same. Prove that the logarithmic function increasing. So logarithmic function means they did not given function, so that you can take log x base e, like that you can take. Okay, let us do these problems in third period. Third period already we have max. Am I right? Okay.